In this video, I'm going to cover a method to create a hybrid Revit energy analysis model. So if you're having troubles creating the energy analysis model from a full-blown Revit model, after spending a couple hours of doing that, I recommend you typically switch gears and do this. This is on par with all the other competing tools within this same space. Those you always have to create an energy model from scratch, separate from your BIM. In this case, you have the opportunity to use the BIM if it's a clean model and works. Otherwise, you can use this workflow, which takes advantage of both Revit massing and Revit building elements together in a combined fashion. So in this case, we can create a mass that represents the building, and then we can also superimpose on that an actual Revit roof element. This mass can be modified or edited in place, and in addition to grabbing faces that you can push and pull similar to SketchUp, for example, you can also grab individual edges like I did here and use the gizmo to pull the mass up to the bottom or within the thickness of the roof. Doing that on both sides just to get the mass to align with the bottom of the roof. Now in 3D you can see we have this sloped roof with this really large overhang. One really important step is all conditioned spaces defined by masses have to have a mass floor. We'll notice that in the energy settings there's a perimeter and core depth of 15 feet. We're going to set these resolution settings to 4 and 6 inches respectively to get more accuracy in this smaller model. And then there was a 0% window to wall ratio, and the building is set to office for occupancy type, which then defines the internal loads. I'm going to duplicate the automatically created analytical spaces view and create an analytical surfaces view. And then in the visibility graphic overrides, we'll switch the settings accordingly. And now we can see the discrete surfaces that were created from this hybrid workflow. We have a single roof surface where previously there were two surfaces, the mass surface and the roof surface. Revit properly pulled those together into a single element. And then if you go back into the visibility settings and expand analytical surfaces, this is a great QA/QC workflow where you can turn off individual surface types. So roofs, shade surfaces, slabs on grade, and exterior walls. And now we're left with the mass element. So that's a great way of making sure that things got translated properly. Now to define glazing, remember the window to wall ratio is set to 0. We can actually use the curtain wall tool. The Revit window family won't work because there's no walls here to host a window, but a curtain wall element can easily define a punched opening just as well as it can define a large glazing area. And these will all translate into glazed openings. So in addition to this, as we continue to develop our design, we might add another mass element attached to the side of this bigger mass. And this might have its own separate low slope roof below the larger sloped roof. We can join those mass elements. We don't actually have to, but in this case I did just to make it nice and clean. And then I'm going to add a few more glazing elements. Now we'll switch to a 3D view and clean up some of those heights. So if this were a punched opening, you could set the sill height and the head height for all of these selected elements. And then on the back we'll just clean this up so that it doesn't go through the roof. And then another interesting option is we can use edit profile because a curtain wall is a wall and walls can have their profiles in an elevation or a section or 3D view modified. So I delete the top edge, draw a new edge, use trim to clean up because we have to have a clean outline. And now we have a curtain wall with a sloped top edge to it that will translate accurately into the energy analysis model. Go to the 3D view and have one more look at it. So the Revit elements being coplanar with the edge of a mass element, end up creating this really clean energy analysis model. And if we happen to know where some interior walls are that define major zones, thermal zones, we can draw them like I'm doing here with some walls. So within the mass element, I'm drawing some simple Revit walls, and then I'm going to create the energy analysis model. And in this case, I have not turned off the perimeter and core automatic thermal zoning, so it's compounded here. So I'm going to go into the settings and set 15 to 0 and uncheck the perimeter zone. Again, 0% window to wall, so that doesn't compound the wall explicit windows that we've modeled as well. So now we have this really clean thermal zones that we've created, and they've been divided up by the interior walls. And then we have these very accurate defined faces. So roof, shade surface, another roof for this little bump out mass element that we added, glazing with solar heat gain coefficient settings, and slab on grade. Slab on grade floor because the floor is coplanar with the level that's set to be grade in the energy settings dialog. So this is a very accurate energy analysis model that we were able to create in just under 5 minutes here. And then we're going to create, just to take this a little further, show an example of a basement. So I'm going to create a level, call it basement, simply pull the bottom of the mass down to align with the basement. We need to make sure we add the mass level for floors. And then we'll actually add a level that defines the grade. So we don't want that main floor to be a slab on grade. So we're going to set a grade to be below that and call that the grade, which would typically be the case. Grade is always just a little bit lower than the floor. And you have to, of course, remember to set the ground plane in the energy settings dialog. As you saw, I didn't, so it was slab on grade again. So to have it be slightly lower, it ends up making an interior floor rather than a slab on grade. And that's a slightly different thing in the context of DOE 2.2 or Energy Plus. So here's a great example of using a hybrid method in Revit to create the energy analysis model.